Hello everybody and welcome back to the 2003 Gauss paper. We're on to question number 3. Okay, so hopefully you've had a chance to take a look at question number 3. I'm just about to, so let's dive in and see what we can see. Alright, so question 3 says, in the game of Switch, the goal is to make the dimes, represented by D's, and the quarters, represented by Q's, switch spots. The starting position of the game with 1 quarter and 1 dime is shown below. So the dime is on the right, the quarter is on the left. Allowable moves are, if there's a vacant spot beside a coin, you may shift the coin into that space. So here's a shift. And you may jump a quarter with a dime or a dime with a quarter if the space on the other side is free. So now this quarter's in the middle, there's a space on the other side of the quarter that's free. And so we can jump this dime over here, and then I guess we end the game by shifting, because the goal is to make the dimes and the quarters switch spots. Alright, so this game, starting with 1 dime and 1 quarter, takes exactly 3 moves. Alright, so this is the game we're going to be working with, and part A says, complete the diagram to demonstrate how the game of Switch that starts with 2 quarters and 2 dimes can be played in 8 moves. So I'm guessing they're giving us 8 spaces here, and we have to figure out how to play the game and get the dimes over to this side and the quarters over to this side. Okay, well, let's get to it, and let's draw ourselves a picture of the game board. That'll be 1 move, 2 moves, 3 moves, 4, 5, 6, 7, and finally 8 moves. Okay. Alright. And we start with I think the dimes are both on this side, and we want them over to the other side, so we'll make the dimes purple, because why not? And we'll make the quarters orange. Okay, so let's get experimenting. I clearly can't jump, because the rules say you can jump a dime with a quarter or a quarter with a dime. So I have no place to jump because I can't jump a quarter with a quarter or a quarter with a dime. So what I'm going to do is I'm going to shift this quarter over. Okay. So now I have 2 options. I mean, I could have incidentally shifted the dime over, but it doesn't really matter. It's a kind of a symmetric play here. So now I have 2 options. I can shift this quarter over here, but then on the next turn I'm not going to be able to do anything else other than shift that quarter back. But I could jump this dime over here. Okay. Now, what can we do here? So I could shift this quarter over, and then I can either jump that quarter there, but then I'll have 2 quarters in a row, and I can't jump the dime over 2 quarters. Or I could shift this dime over, and then I'd sort of have to jump it with the quarter. Let's try that. So if you're actually doing this contest, there's probably a little bit of experimentation with this question in particular. So what we're going to do is we're now going to take the middle quarter and we're going to jump over the right-hand side dime. Okay, now this I like to see. There's a sort of a degree of symmetry here in the problem. So basically, at this point, I should think that maybe if I sort of undo all my steps or something like that, then maybe I can get a solution. What I'm going to do is I'm going to take the other quarter and jump this dime. And then I really only have the one position left because I don't want to backtrack, so I got to move this dime over. And we're getting close to the end, so everything should work out pretty soon, I hope. Otherwise, I have to go back and re-examine what it was I was doing. So jump the middle quarter with the right-hand side dime, bring him over to the side. And then I would shift the quarter over. So I think I'll just label it with S for a shift. So I got from the previous stage to this line here with a shift. Then I did a jump. Then I did a shift. Then I did a jump. Then I did a jump. Then I did a shift. Then a jump. And finally a shift. Okay, that way if I need to go back and re-examine what I did, it's clear in my mind now, so I'll write it down. Shift, jump, jump, shift, jump, shift. Okay. So that's what we did, and we were able to fill it in. And so the game is clearly playable in 8 turns here. Okay. And, we don't have a C part, we just have a B. Okay, B. By considering the number of required shifts and jumps, okay, so actually it might be good that in this part A I explained when I shifted and when I jumped. So by considering the number of required shifts and jumps, explain why the game with 3 quarters and 3 dimes cannot be played in fewer than 15 moves. Okay. So sometimes they ask you these sort of game-like questions, and they say, show that this can't happen in this certain number of moves, or show that there can't be this kind of strategy. And they can be tricky. I won't lie, they can be tricky. And right now I'm not seeing a particular way to do it. So by considering the number of required shifts and jumps, well, how do I know how many shifts and jumps? I think I might be able to get a handle on a jump, because jumps are specifically dime over quarter or quarter over dime. It's never quarter over quarter or dime over dime. Sometimes the rules that they don't give you are just as important as the rules that they do give you. So when they say quarter and dime and quarter, you also have to remember you can't jump a quarter with a quarter and a dime with a dime. And that might be important. Shifts, I think, are going to be very hard to understand. And jumps, I think, that might be a little easier because you have to jump a quarter with a dime. Okay. So let's see. Is there a pattern here? Yeah, there's a degree of symmetry. You go shift, jump, and then we reverse the order to go back. But it's not quite like we reversed everything. And even if in part A, even if this pattern does work, there's no way to guarantee that a smaller pattern won't work with 3 quarters and 3 dimes. And incidentally, let's draw what we're working with. So the game starts with 3 quarters and 3 dimes. So we're going to have 3 dimes over here on the right. And 3 quarters over here. Okay. So let's just focus on the jumps, just for a moment, okay? So this first quarter here, he needs to end up over here. And to do that, I mean, he can't shift all the way there. He can't, because there are dimes in the way, and there will always be dimes in his way. But at each step, eventually he's going to need to jump over this dime, and then he's going to need to jump over this dime, and then he's going to need to jump over this dime. So if we go back to look at our part A case, what I'm claiming is this first quarter, and we can keep track of him just by considering where he moves, he needs to jump over each dime, right? So he jumps over this dime to get down here, but actually the other dime jumped over him. It was the first dime that jumped over the first quarter, not the first quarter that jumped over the first dime. Okay. So maybe this quarter doesn't need to jump over each dime, but he does need to be involved in a jump. And the same has got to be true for the other quarters. So they've either got to be the jumper or the jumpee, and that means the person who was jumped over. So why is this true? Because each quarter starts to the left of every dime. Right, we put the quarters on the left, the dimes on the right, but must end up on the right of every dime. So what does our end state look like, just to remind ourselves? 1, 2, 3, 4, 5, 6, 7. So the game needs to end up like this. Every quarter is now to the right of every dime. And the only move that allows us to switch is a quarter on the left or on the right. Shifts don't. If you shift and you were on the left of all the dimes, you're going to still be on the left of all the dimes because you haven't hopped over any dimes. So the only move that allows us to change whether or not a quarter is on the left or the right of a dime is when we do the jump. Okay? So this tells us a little bit about what we need to do with the jumps. Now, we can't say that every quarter has to jump every dime, but the quarter needs to swap positions with every dime. So the quarter must either be jumped by a dime or jump over a dime. So there's definitely a jump associated to each quarter and dime pair. So the 3 quarters must each jump 3 dimes. 3 times 3. So that equals 9, so we need at least 9 jumps. So we have 9 jumps that are guaranteed. And by the same reasoning, 2 dimes jumping 2 quarters, we would need 4 jumps in the minimum in our game in A. And let's see, we have 1, 2, 3, 4 jumps in this first game. And actually, we're given a little extra information. We're given a game with just 1 dime and 1 quarter. There should just be 1 jump, and wouldn't you know it, there is. 1 quarter times 1 dime, we need at least 1 jump. Fantastic. Okay, so it looks like we're on the right track, and we've actually discovered something useful. So, of these 15 moves, we've guaranteed that there need to be at least 9. Okay, so now we need to guarantee, I guess, that there need to either be some more jumps, which I don't think we can guarantee, but there need to be some more shifts, at least 6 shifts. Okay. So, there need to be at least 6 shifts. How would we possibly show that? Alright, so, this first quarter, he goes over here, he gets jumped, then the dime moves over and he jumps into this spot, and that's where he stays. And then the second quarter eventually follows him in. And this first dime, he jumps, and then eventually he shifts over, and the second dime follows him in. Dimes can't jump dimes, so I mean that's part of the rules of the jump. It has to be quarter with dime or dime with quarter. So I think the relative order of the quarters and the relative order of the dimes has to stay the same. Is this helpful, or is this just a distraction I'm coming up with? All right, let's write down the rule. So quarters can't jump quarters. And dimes cannot jump dimes. So that means the order of the dimes and order of quarters stays the same. Now, what do I mean by that? Okay, so we sort of start 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so we start with our quarters over here, and I could give them an order. I could say quarter 1, quarter 2, and quarter 3. And what I mean by that is, at the end, we're going to have quarter 3, quarter 2, and quarter 1, and they're going to be in the exact same order. Same with the dimes. I'll number them dime 1, dime 2, dime 3. So dime 1 will be the first dime who gets into his proper spot. Quarter 1 will be the first one who gets into their proper spot, and they have to be this far over. If the dime 1 ended up here, then that would mean that at some point dime 2 jumps over dime 1. So this is the start, this is the end, and then something happens in the middle. But at the end, we're still going to have this same order. Okay. So let's look at quarter 1. We know he's involved in at least 1 jump with each dime that we have here. Okay. And we know that no matter what he does, he's going to end up over here. So he might shift and jump, and then shift again or something like that. I might shift, jump, be jumped, and then shift, something like that. But he's going to move over 1, and then he would move over 2 spots, and then 1 spot. But overall, he's got to move 1, 2, 3, 4 spots. So if we were just playing with shifts, and ignoring the fact that there are dimes in the way, he's got to move over 4 spots. Same with Q2, same with Q3, same with D1, D2, D3. They all have to move exactly 4 spots. So each coin must move to a location 4 spots away from their start. So that gives us a total change of 6 coins, 4 spots per coin, 24 spots. So overall, the coins in total need to sort of change by 24 spots. Does that mean they move 24 individual spaces? No, not at all. Because, I mean, if we were just doing shifts and you could somehow sort of phase through dimes or occupy the same space as dimes, then yeah. But jumps don't move us a single spot at a time. They move us, they move one of the coins 2 spots. Okay. Shifts move 1 coin by 1 spot. Jumps involve 2 coins. They move 1 coin by 0 spots, and they move 1 coin by 2 spots. Okay. So we know we need to have sort of a change, an overall change of 24. We have 9 jumps, and that's we move 2 spots per jump. So 24 spots minus 18 spots is equal to 6 spots left over to change. Okay, so do these 6 have to be with shifts, or could we do 3 other jumps? That's the real question. If we can show that these spots here have to be shifts, then we'll have 9 jumps and 6 shifts. Because each jump moves 1 coin by 2 spots, so in theory, the 6 spots that are left over could be handled by 3 jumps. So why isn't that true? Why won't that work? Spending a lot of time on question number 3. So is it obvious that these need to be shifts? Because it's spent a while on B part here. Maybe if we know that those 9 jumps have to be are the only ones that will make us any progress. So what I'm thinking is, if we have 9 jumps, then that definitely, like, if we have 9 jumps specifically where each dime jumps a quarter, each quarter jumps a dime, and they're moving towards the spots they need to be, then that should be the only 9 jumps we'll need. Any other jump would change the left-right position of 1 quarter relative to 1 dime, and we'd sort of have backtracked. So I have an idea. Let me sort of talk it out. We get at least 6 spots left to move, and that's assuming that all the jumps are moving quarters towards quarters towards their final dime spot and dimes towards their final quarter spot. And if we were to have a 10th jump, then that would mean that one of the quarters is moving away from its final spot. So basically what I'm arguing is here is jumps are good if the 2 spots being moved are moving a dime to the left or a quarter to the right, and the 0 spots represent no change in the quarter or dime respectively being jumped. So if we were to have another jump, so we would take a quarter, let's call them QI, and a dime DJ. And it would move QI back to being on the left of DJ. Our 9 jumps that we have accounted for all change a quarter that's on the left of a dime to being on the right of a dime. Now, if we had a 10th jump, then that would mean at some point one of our 10 jumps would move a quarter to the left of a dime, and this is counterproductive. So what I mean by this is, let's say the quarter jumps over the dime. So QI, the ith quarter, I don't know if it's 1, 2, or 3, it doesn't really matter, jumps over the jth dime. Well, then he's definitely moved 2 spots. But in the wrong direction. So more jumps does not help. It only, you can move a total of 24 spots with 9 jumps and then 3 more jumps. That is absolutely true. But they will not be moving the quarters or dimes in the right direction. Only these first 9 jumps are needed. Only 9 jumps are needed. So we'll move quarters to the right, and we'll move dimes to the left with our remaining shifts. So we need 9 jumps, and we need at least 6 shifts. And we've concluded we need at least 15 moves. Okay. So that was a very interesting little game. And I probably could have cleared things up a little more if I'd said not that they need to move 24 spots, but that each quarter needs to move 4 to the right, and each dime needs to move 4 to the left. And that might have cleared things up a little and made this a little easier to read. So I might lose a style mark or something, but for the most part, the answer is there. So let's get ourselves a brand new piece of paper, and in the next video, we're going to move on to the last question on this Galois, because remember, I'm not going to be doing these extensions. What is the extension for this problem? Explain why the game with n quarters and n dimes cannot be played in fewer than n times n plus 2 moves. Okay, interesting. I think all the work that I just did for problem 3, you can probably generalize it. N times n plus 2, it probably comes down to, so you'll have n squared jumps, and you'll have 2n shifts that you need. And that'll be because you need to move each quarter n plus 1 moves to the right, and each dime n plus 1 moves to the left. So that means that you'll have a total of 2n times n plus 1 moves that you need to do. N squared of those will be jumps, and that'll leave you with 2n shifts. Interesting. But like I say, we're moving on to question number 4, and that'll be the last video in this particular Galois. So hopefully you guys will join me then, and I look forward to the next question.